Welcome to the channel. I'm Carlos Ortega, and I'm excited to explore the amazing worlds of physics and chemistry with you.
You can run a grueling marathon, completely sweat through your clothes, and finally collapse right at the finish line. But ask a physicist, and they might tell you that you didn't go anywhere at all, that your total movement is a mathematical zero. To understand how that is physically possible, we have to ignore human effort for a minute and look at how the universe actually measures space. Our everyday intuition about what it means to move is often flawed. To reach the truth, we have to isolate the variables that actually matter. Let's put our test subject Leo in the middle of a park. Right now, it is completely impossible to measure his movement because we are missing a critical tool. That tool is what physicists call a reference system, or sistema de referencia. It is also commonly known as the origin. The origin is our absolute starting line. If we don't lock down a point zero, like a specific oak tree standing right next to Leo, we have no way to prove his position has changed. Without a fixed point of reference, any measurement is just a meaningless guess. The origin literally gives reality an anchor. Now, Leo is hungry. He walks from our reference point tree over to a distant ice cream cart, taking a highly inefficient, zigzagging path across the grass. That specific winding physical path he just took is called the trajectory, or trayectoria. If we follow right behind him with a tape measure, tracking every single erratic step, the total length we record is the distance. Distance is a scalar magnitude. That means it only cares about the total accumulated amount. It acts like the odometer in a car, rapidly spinning upward the more he walks. A scalar measurement tells us exactly how much energy Leo burned on his walk, but it is entirely useless for figuring out where he actually ended up.
Physics has a shortcut to bypass that chaotic trajectory. It's called displacement, or desplazamiento. Displacement ignores Leo's winding path entirely. It only cares about drawing one perfectly straight, direct line from the starting tree to the ice cream cart. Look at this graphic. This solid blue arrow represents what a vector is, a perfect, uninterrupted line. Displacement is a vector magnitude. Unlike an odometer, this vector is demanding. It requires a specific size, but also a direction and heading. While the scalar distance gave us a huge, vague number of total steps, the vector displacement gives us a tight, highly specific set of coordinates. Vectors ignore the journey. They ignore the sweat. They only measure the absolute, factual difference between the start and the finish. Leo gets his ice cream and decides to walk all the way back across the park, finally sitting down against the exact same tree where he started. Let's check the distance. That scalar odometer never stopped spinning during his walk back, which means his total distance traveled just doubled. From a human perspective, he's done twice the work and covered a massive amount of ground. But what does this exhausting return trip mean for our strict vector rules? Here is the mathematical tool to crack the case. The formula for displacement. You take the final position and you subtract the initial position. Let's plug in Leo's coordinates. Because his final position is the exact same tree as his initial position, those numbers cancel each other out entirely. Since the start and end points are identical, the displacement arrow shrinks to nothing. So mathematically, Leo never moved at all. Physical movement is defined by the final change in position relative to the start. If that difference is zero, the universe considers the object stationary. Case closed.